Hello, welcome to another video on SAGEMATH. In this video, we are going to see how derivatives of functions can be determined using the SAGEMATH system. We also will discuss plotting of the function fx and its derivative, plotting of a function fx and its derivative together. Using an example, and then we will discuss how to find the higher order derivatives of a function. Finally, we can see how partial derivatives can be determined. So these are the important important topics that we are going to see in this video. First, we are going to take the derivative of a function. Here the given function is fx equal to x cube minus x. The function is fx equal to x cube minus x. Then if you want the derivative of this function, you can use diff. Derivative of the function can be determined using diff function. Diff, then in bracket fx with respect to which variable you want to differentiate it, that you can give after this function, definitely function, after giving that function, the comma that must be separated by comma, then the bracket must be closed. So as a result you will get that it is 3x square minus 1, and that is the derivative of this function. So another example is given here, diff of sin x, but here without defining that function directly, you can give a function that in that derivative diff of command inside diff of command, and you can take the out. You can differentiate. You can obtain that output. Then you will get the output as 2 star x star 2 into x into cos x square. Okay, when gx equal to after that we define gx, a new function. Gx equal to e to the power of minus 10 into x, e raised to minus 10x. Then derivative diff of gx comma x gives us the derivative. Okay. Therefore we are going to check whether these results are correct. You can verify that. Okay, then when we check, you can see that the cap is not correctly displayed. So that definition is okay, and there is no error. So if you want derivative of fx with respect to x, then you can copy it and then use it, diff of fx comma x, and now we can take the output. What is seen there? It is 3x square minus 1. That is the derivative. Okay. If you want to differentiate, repeated differentiation, that we are going to see it after one or two sections. In this video itself we are going to see whether how can the method to obtain higher order derivatives. So following this syntax, you can obtain the derivative of a function. See another example. You can this is another one. You can directly use the diff function to find the derivative of a given function. Sin x cap actually. Okay. So we have 2 into x into 2 into x into cos x square as answer. So to differentiate and we next we define a function gx. Okay, that is after that it is typed and gx equal to e to the power e cap minus of 10 into x, minus 10 into x, and then you can use that command diff of gx comma x to obtain the derivative. Use this command diff of gx to obtain the derivative. Yeah, we have the derivative is displayed there. You can verify it with this manual. Okay, after that another example is given. You can use this example if you want the derivative of x cap x or x square x sorry, x raised to x. If you want the derivative of x raised to x or x cap x, you can use the command derivative of x cap x. So that is x square x cap x into log x plus 1. This way you can find the derivative of any function. All functions you can find the derivative. Okay. Next we have in the next section we have the plotting of fx and f dash x together. So for that the function fx equal to x cube minus x is given. If that function fx is already there defined the same way, then since fx is equal to x cube minus x is already defined, if there is no change in the function after defining a function, if there is no change in the function, then you can use. You do not want to. You can skip this step actually. Then you can recall that function. You can, and then you can work with it. After recalling that function, you can work with that function. Here f prime x equals derivative of fx comma x. Okay. Here we define a variable, and the new variable f prime of x. That is then the value of derivative of fx comma x will be stored there. Okay. F prime equal to f prime of x equal to derivative of fx derivative derivative of fx comma x. Derivative of f fx comma x. Derivative of fx comma x. Okay. Then you can use the show function, show f prime x, to obtain the output. Yeah, 3x square minus x, you can obtain that of 3x square. Yeah, 3x square minus 1 is the output. Then we have obtained the correct output. Okay. Next, the question is, how can we plot both fx and f dash x? You can use the plot command, plot fx, then comma x, comma minus 2 2. This minus 2 and 2 specifies the lower and upper limit of the range in which the plot will be displayed. So minus 2 2, and then color equal to the required color is color equal to blue, plus plot. In addition to that, this is the first plot, first curve, and in addition to that, the system must plot the other function also. So for that plot f prime is the location at which this the derivative of the function is stored. So the derivative of that function, okay, yeah, it is f prime. It is the location where the derivative is stored. Therefore, using this plot function, you can display that derivative function. So plot of f prime and x, then comma x minus 2 2, you can use the color red. So by copying it and pasting, plot of x, CLOR color, color equals blue. The color equals blue, and for the first it is blue. For the rest, you can put that bracket and plus. You can put the plus. See, for convenience, you can copy the first plot. It can be copied and pasted there. Then you have to make changes. Fx, instead of fx, you have to type a gx and plot gx. Range of x is okay, it's correct, but the color must be changed to red. Red, okay. I think we can take that output. There is no error. I hope that. Yeah, there is no error. It is displayed here, but the scaling. Yeah, it is displayed, but what is the problem? It doesn't show the so it does not appear as in the figure here, but the reason is you have to find the reason. It's because plot fx, then x minus 2 2 color equals blue, then plus plot gx, gx comma x minus 2 2 color red. Okay, now we'll try again. Okay, the same effect is there, and it's due to the scaling. Maybe due to scaling, but okay, then we have to find the reason for that. Okay, it may be due that a different figure is obtained. It is because of the scaling effect.